Alright guys, today we're going to do the 2003 AP Physics B free response question, Form B. So, it's asking, an electric field, E, exists in the region between two electrically charged parallel plates shown above. A beam of electrons of mass m, charge q, and velocity v enters the region through a small hole at position A. The electrons exit the region between the plates through a small hole at position B. Express your answers to the following questions in terms of the quantities m, q, E, theta, and V. Ignore the effects of gravity. So part A, Roman numeral 1, is asking, on the diagram of the parallel plates above, draw and label a vector to show the direction of the electric field E between the plates. So here we have a positive and negative. You always go out of positive into negative, so that is E. Part Roman numeral 2 is asking, on the following diagram, the dot, show the direction of the forces acting on an electron after it enters the region between the plates. So the force of an electron, the force on the electron will be towards the positive, so it'll go down, that's Fe. Roman numeral 3 says, on this diagram of the parallel plates above, show the trajectory of an electron that will exit through the small hole at position B. So, if an electron is entering through there and wants to exit there, you'll just have that, projectile motion. And then there, you have your horizontal acceleration and no vertical. Next, part B, determine the magnitude of the acceleration of an electron after it has entered the region between the parallel plates. So part B, it wants the acceleration, so B, you have F is equal to QE, but F is also equal to MA. You could set those equal, and you get MA is equal to QE, and to find A, just divide out M from both sides, and you get QE over M. Part C. Determine the total time that it takes the electrons to go from position A to B. So, because V is vertical, we have V up, and T of half the up to the middle will be V up, T equals V up over A. And because it's a component, V up is equal to V sine theta. So when you plug into the formula, T is equal to V sine theta over A. But that's only half the time, so you want to double that. So you have 2T, which for T total will equal 2V sine theta over A. And because we have A, which we found over there in part B, we'll have T total equals 2V sine theta over QE over M, which is 2VM sine theta over QE, which equals T total. T. So the next part D, is asking, determine the distance between positions A and B. So for that, we have our distance is equal to VT. And because we're horizontal, V is equal to V cos theta. And our time is equal to this from part C. So all you have to do is D equal V cos theta over time, so 2VM sine theta over QE, and you get D to be equal to V becomes squared, so you get 2v squared m sine theta cosine theta over q e. There's your distance. And if I could fit part E over there, it's asking, now assume the effects of gravity cannot be ignored. How would the distance d change for an electron entering the region at A and leaving at B? We would have a downward acceleration. So downward acceleration would increase. The electron would therefore, have a smaller distance in electric field, thus having less time as well. And that's it for this problem.